There is a common misconception when people think about EMF, and they think it is all the same thing. Within the home, there are multiple types of EMF, and they sit on different parts of the electromagnetic spectrum. They emanate from different sources, they behave differently, and they require different meters to measure. This video is designed to give you a brief practical overview of what electromagnetic fields we find in the built environment for you to better understand exposures and what you can do about them. The first EMF we find in the built environment is called radio frequencies, or RF. Sources of RF come from wireless technologies, things like mobile phones, Wi-Fi, Bluetooth, and smart technology. To measure radio frequencies, we use an RF meter. Now, before you go out and purchase one of these, I highly recommend you watching my video on the problem with most consumer level RF meters. Spoiler alert, accuracy is a real issue with these devices. The characteristics of radio frequencies are they're easily shielded. They are technically challenging to measure due to the multiple frequency ranges. They require a high level meter. A lot of cheap meters just really aren't accurate. And the type of frequency is they're very fast pulse-like technology. While we're on the topic of RF, I need to bring up and mention an emerging EMF known as millimeter wave. At the time of making this video in Australia, the vast majority of everyday telecommunications and wireless operate within the RF frequency bands. A quality RF meter that measure between 200 megahertz and 8 gigahertz will register the RF in your home. However, they're throwing a new one at us, and it's delivering the same services, but it's much faster, much faster, and no RF meter on the market will even register it's there. Measuring millimeter wave requires a different meter like this one, the Safe and Sound Millimeter Pro. And at present, millimeter wave is primarily developed in high density areas of major capital cities rather than the suburban and regional locations. So if that's you, it's something to be aware of. The second major source of EMF in the built environment comes from electricity. And you might be wondering, but isn't electricity contained in the wiring? And the answer is yes and no. The electrical conductor itself is insulated, but there are actually two measurable fields that are not contained by the insulation. The most significant field when it comes to electricity is what's known as AC magnetic fields. A power cable can have voltage or potential energy, but if the appliance is not in use, there will be no magnetic field. But the instant something is switched on, there is a current and a magnetic field is present. The higher the current, the stronger the magnetic field. The characteristics of AC magnetic fields are they're very hard to shield. AC magnetic fields basically go through everything. Thick concrete walls, steel, even most shielding products. It goes straight through. But the type of frequency is it's very slow and a steady, smooth sine wave. This makes it much easier to measure from a technical perspective and also from a meter perspective. Consumer level meters such as this one are okay for testing your own home, things like that. If your EMF testing technician turned up with one of these, I wouldn't be happy. You want something a little more substantial for that. Before I continue, I need to explain something in context. EMF is a complex and it is still a debated field. And I value my credibility and I base my services, teaching and overall approach on the best scientific evidence applied to real world environments. And at this point in time, the strongest and most consistent body of research examining the potential biological effects of EMF on humans are on radio frequencies and AC magnetic fields. In my professional assessments, my online course and my general approach, I place far more emphasis on these two fields. There are, however, two other fields present in the home, and while I don't prioritize them, I don't dismiss them either, particularly if you are sensitive to EMF. AC electric fields is created by voltage. So if there is power in a cable, it will have an electric field around it, whether the cable is in use or not. The characteristics of AC electric fields is they're relatively easy to shield. The field drops away at around 1.2 meters. Consumer level meters, such as this one, is okay for doing your own house. Again, I wouldn't accept that from a professional. The final area we sometimes assess is what's commonly referred to as dirty electricity. This is a non-technical term used to describe high frequency electrical noise that can be introduced into household wiring. In a typical Australian home, electricity operates at 50 Hertz. However, many modern electronic devices don't simply use that 50 Hz power directly. Instead, they convert it using what's called switch mode power supplies. During the conversion process, high frequency transients or harmonics can be introduced back into the wiring system. This electrical noise is what's commonly labeled as dirty electricity. Now, it's important to understand that this is not a separate field like RF or AC magnetic fields, rather it's distortion of high frequency components riding along the electrical wiring system. Measuring dirty electricity is a little bit different to every other type of EMF, where rather when we're testing a frequency out of the air, with dirty electricity, we literally plug it in. When we plug into the electrical grid, our meter will tell us what sort of transients are on the line. And that concludes the EMF we find in the built environment. If you found this useful, please subscribe to my YouTube channel. And if you're interested to learn, I have an online course on my exact methodology on how I do an EMF assessment. I have an online course available, and I also have Zoom consultations available for any questions you have at EMF on my website, www.expandedconcepts.com. Thanks for watching.